ES number on both routers should be same. So we have configured same autonomous system number on both router. In last class, we had discussed autonomous system number as well, I think. What is autonomous system number? I have give you one example of society. Have you remember?
Yes.
So autonomous system number should be same on both router. After that, to configure RIP on router number 1, just I need to run command router RIP EIGRP and then ES number 10, and after that we will define network command network 12.1.1.0 12.1.1.0. Once I will hit enter over here, router 1 will start sending one hello message from this interface. It will send one hello message from this interface. This is nothing but hello message of router 1. After that, we need to enable EIGRP on router 2. So here also I will run command router EIGRP ES number 10 and then network 12.1.1.0. Once I will hit enter over here, after running this command, actually router will check that this network is running on which interface. This network is running on this interface, so it will start sending hello message from this interface. It will also send one hello message. Done. So both router will exchange first what? Hello message. Getting my point? Both router will exchange hello message first. Inside the hello message, there are some parameter, as I told you, that ES value. Both hello message will carry ES number of router, and if ES number will match, then only these two router will become neighbor. So see, when router 1 is sending their hello message, inside that hello message ES number will be 10, and router is receiving one hello message. Inside that hello message also ES number is 10. Router 2 is also sending what ES number? 10. So both are sending same autonomous system number. Am I right?
Yes.
So here both router will become neighbor. Both router will become first neighbor. Now who is neighbor of router 1? Neighbor of router 1 is router 2. And who is neighbor of router 2? Router 1. Done. And now let's say router 1 have some prefixes, 100 prefixes. So it will share these 100 prefixes with their neighbor. So EIGRP router share prefixes with their neighbor only, not directly to the router. If we will discuss about the RIP routing protocol, guys, so when we are enabling RIP, directly routers are sending update message. In that update message, it is sharing network information. But in case of EIGRP, first router will become neighbor and router will share network information with their neighbor only. Getting my point?
Yes.
And EIGRP maintain three types of table. First is neighbor table. Neighbor table. Inside the neighbor table, there will be information about neighbor. Then second table is topology table. Topology table. Inside the topology table, EIGRP router will install all possible path or prefixes, and then it will maintain one routing table, and inside the routing table it will install best path only. Done. RIP maintain how many table? Only one table. Inside the one table there will be all prefixes. EIGRP maintain three types of table. Neighbor table. First it will store the neighbor information. After that, with their neighbor it is going to exchange topology table. And on topology table it will run dual algorithm. Diffusing update algorithm. So if anyone will ask you what algorithm EIGRP protocols use, so it is dual algorithm. Dual means diffusing update algorithm. Diffusing update algorithm. So On CIGRP, we will create topology table. On that topology table, it will run dual algorithm and it will calculate best path, and it will install best path in their routing table. Let me show you. This is the concept of EIGRP, like how EIGRP works. Let's say I have two router. And on router number 1, I have one LAN. Let me connect one LAN here, switch, and let me take one PC as well. This is my topology, very simple topology. Can by default PC1 and PC2 can communicate with each other?
No,
Not communicate with each other. Why?
because there is no routing between.
Between router 1 and router 2. Because there is no routing between router 1 and router 2. So on router 1 and router 2, I am going to configure what? EIGRP protocol for the routing purpose. Okay, first of all, let me show you here. Let's say I am using one network, that is 10.1.1.0/24. Okay, here I am using 10.1, not 10, let's say 20.1.1.0/24. And between router 1 and router 2, or let's say IP address of this PC is 10.1.1.1, and the gateway IP address is, let's say, 10.1.1. Means router interface IP address is, let's say, 10.1.1. 10.1.1.10. Okay, here this side the router gateway IP address is 20.1.1.10, and IP address of PC2 is, let's say, 20.1.1.1. Done, guys.
Yes.
Here IP address is, let's say, 12.1.1.1, and here IP address is, let's say, 12.1.1.2. Done. First of all, I am going to configure IP. So let me take you to router 1. This is my router 1. Let me increase the size of console so that we can see the entire things. On router number 1, just let me configure one IP. To IP interface F0/0. What will be IP over here? 12.1.1.1, 255.255.255.0, exit interface F1/0. Yes,
We can.
We can see your job.
you cannot see my screen.
No, we can see your screen, but stuck. It doesn't go further.
We see your screen, but it's stuck.
Still it's stuck. Let me do one thing. Let me stop it and let me share my screen again. I'm going to shift, the taking class on Google Meet to Zoom. I think Zoom is better than Google Meet.
Yeah, Zoom is better.
Now is my screen visible and working?
Yes.
So on F1/0, I am going to configure IP address 10.1.1.10 255.255.255.0. So I have
Then
configured IP address. So IP
It
interface
doesn't work,
brief.
sir. It
Yes,
doesn't work, sir. No, it doesn't work.
it's not working.
can you move your cursor to see is it working?
Yeah, I
No, it
am
doesn't.
moving my cursor. Let me check my internet speed. Internet is also working fine. We don't have any problem with internet.
I think you share your screen just only GNS3, but now you move the router one somewhere else.
No, I have shared my entire screen, not GNS3 screen only.
Okay, we do not see your cursor. Oh. How about Soha? Do you see his screen?
No.
Wait. Now tell me. Now is my
Yes.
screen visible?
Yes, can you
Yes.
go
And
from
console?
the beginning?
Yes. Can you
Yes.
type in?
Yeah. Type
Exclude
something, please.
unassigned.
Yes.
Yes.
Good.
Yes.
Okay, so now that means it's working. So IP interface brief and say exclude unassigned. So I have configured IP address on these two interface of router 1. Done. Let me configure IP address on router 2. So this console is also visible to you, I think.
I
Yes.
can see it.
Config T interface F0/0 say no set and IP address 12.1.1.2 255.255.255.0. So I have assigned this IP address on F0/0. Done. Interface F1/0 say no set and IP address 20.1.1.10 255.255.255.0 and so IP interface brief exclude unassign. Done. IP configuration on router 1 and router 2 is done. Yes, guys.
Yes.
Yes.
Now I am going to configure IP on PC. Let me take you to PC1 and here I am going to say IP 10.1.1.1/24 and gateway IP address 10.1.1.10. And I am going to check the connectivity between PC1 and router 1 gateway. Ping 10.1.1.10. So see, ping is working. That means there is connectivity between PC1 and router 1. Okay. Okay. And if I will ping PC2, ping 20.1.1.1. So it will not work. PC2 IP address is 20.1.1.1/24 and gateway is 20.1.1.10. So if I will ping from PC1 to PC2 now, will ping work?
No.
No,
Ping will not work because router 1 don't have root 420 network. If you will check routing table of router 1, so IP route, so you can see there are only directly connected network. There is no any information about 20.1.1.0 network. Yes.
Yes.
Okay, so that's why ping will not work. This ping is not working. Destination is unreachable. Now I am going to configure RIP. So see guys, configuration of RIP is very simple. On router number 1, you need to run command router EIGRP. So not RIP, EIGRP. Router EIGRP and then autonomous system number. As I told you that autonomous system number range is 1 to 65535. Between this range you can use any autonomous system number. Let me use 10. And this is command to enable EIGRP protocol on router. After that we will use network command to advertise prefixes, or you can say to enable EIGRP on interfaces of router. 10.1.1.0. This command will enable EIGRP on which interface of router 1?
LAN.
Very good. And network 12.1.1.0. This command will enable EIGRP on which interface?
Between two routers.
Yes, F0/0.
Ah. Just like that.
Now, if you want to check the routing protocol, command is show IP protocol. So here we can see routing protocol which is running on router is EIGRP autonomous system number 10. And distance for internal is 90 and external for 170. We will discuss both. For now, just consider this distance 90. Hope it's clear.
Yeah. One question here, small question.
Yes.
So in router 1, you configure EIGRP on LAN 1 and like in both LAN networks, but
Yes.
between two.
LAN and WAN. On F1/0 also and F0/0 also I have enabled EIGRP.
Yeah, but you didn't enable in 12.1.1.0.
12.1.1.0. Yes, I have enabled it. Here you can see I have run 2 command.
Okay.
I have run 2 command. Getting my point. And if you want to check the interfaces in EIGRP, you can run show IP EIGRP interface command to check on how many interfaces you have enabled EIGRP. So you can see I have enabled EIGRP on fast Ethernet 1/0 and fast Ethernet 0/0. Getting my point. And as I told you that EIGRP maintain 3 types of tables. So IP, EIGRP, neighbor. This is command to check neighbor table. In neighbor table you can see we don't have any information now because router 1 don't have any EIGRP neighbor. Yes or no?
Yes.
Then topology table. So IP, EIGRP, topology. This is topology table. Inside the topology table, router 1 have put 2 network. 12.1.1.0 and 10.1.1.0. Are you able to see 20 network here? No. So router 1 have designed their topology table. Inside the topology table they have put both network which you have advertised in EIGRP. And so IP route EIGRP. This is EIGRP routing table. Inside the routing table also you can see EIGRP have no any prefix. So these are 3 tables of EIGRP. So IP EIGRP neighbor, so IP EIGRP topology, so IP route EIGRP. Done. And one command is there, so IP EIGRP interface to check the interface. EIGRP enabled interface. Done. Now let me take you to router 2. I am going to configure EIGRP on router 2. Here also, so IP EIGRP neighbor. You can see there is no any EIGRP neighborship and EIGRP is not enabled on this router. So IP protocol, you can see routing protocol is NSF. Means there is no any routing protocol configure on this router. Done. And so IP EIGRP topology. So you can see topology table is empty, routing table is empty, right? We are not running any routing protocol. So let me enable EIGRP. Command is router EIGRP and AS number. As I told you, AS number should be same. So what AS number we have configured on router 1?
10.
10. So here also AS number should be 10. And then network 12.1.1.0 and network 20.1.1.0. 0. And once I have run network 12.1.1.0, I have one log message. Dual neighbor change EIGRP IPv4 AS number 10 neighbor is 12.1.1.1. Who is neighbor of router 2?
12.1.1.1.
1. And how you can verify? So IP EIGRP neighbor. You can see neighbor is 12.1.1.1. On which interface? On fast Ethernet 0/0. In the same way on router number 1 also you can verify it, and we have one log message on router 1 as well. See this log message. New adjacency of EIGRP. Done. And now I am going to check show IP EIGRP neighbor table on router 1. So IP EIGRP neighbor 12.1.1.2 is neighbor, and so IP EIGRP topology. In topology table now we have 20.1.1.0/24 network. Yes or no?
Yes.
And in the same way router 2 will have which network? 10.1.1.0 network in topology table. So IP EIGRP topology on router number 2. I'm running this command on router 2. So here you can see in topology table 10 network is there. Done. Now on router number 1 I am going to show you routing table. So IP route EIGRP. So inside the routing table of EIGRP there is only one network, that is 20.1.1.0, and AD value is 90, and this is metric. You already know how to calculate metric. Yes or no? We have already discussed how to calculate metric in EIGRP. 10 to the power 7 upon least bandwidth plus total delay upon 10 whole multiplied by 256. Yes or no?
Yes.
And now both router have prefixes, so PC1 can communicate with PC2. Let me take you to PC1, and again I am going to ping this IP address and see if this time ping is working. Done.
Yes.
Is it clear to everyone?
Yes.
Now guys,
Yes.
dual algorithm have some terminology of dual algorithm. As you know, dual algorithm EIGRP uses dual algorithm for best path selection to calculate routing table. Dual algorithm. And if I will talk about the terminology of dual algorithm, so we have some terminology like FD. FD is nothing but feasible distance. Feasible distance, in short we call it FD. Then we have one more term, that is RD, reported distance, or we can say advertised distance. In short we can say AD or RT. Then third terminology is successor. And the fourth terminology is feasible successor. Done. See guys, what is FD? FD is the total distance from source to destination. Like on router number 1, if I will show you the topology table, so IP EIGRP topology. See, we have 20.1.1.0/24 network. What is FD? FD is 30720. Yes or no? This is guys metric from R1 to this network. Means total cost, total metric to reach in this network is 30720. Getting my point? FD is nothing but total distance from source to destination. Total distance from source to destination. And this is nothing but RD. RD means reported distance. Reported distance, this is RD. Whenever EIGRP will receive a prefix, a network information, it will calculate two information, FD plus RD. FD is, as you know, metric, total distance, like how you calculate metric, and RD is the total distance from neighbor to destination. Destination is 120.1.1.0. So distance from router 1 to reach in this network is what? 3 30720 and distance to reach in this network from their neighbor. Who is neighbor? Router 2 from their neighbor is this one. Means this is FD of R2. This is FD of R2. If you want to see the topology table on R2, so IP EIGRP topology, you can see for 20 network FD is what? Means
I think
yes, let me make you understand first. Means from router number 2 to reach in this network, FD is means what metric router 2 is calculating?
no, your screen is stuck again. Doesn't move.
It's not working.
No, just stuck there.
Oh my god, why it's happening today? Now is it visible?
Let's see what happened. No, stuck there.
What should I do? Can I send you the joining link of Google Meet again?
Yes.
I think I should close this Google Meet and let me share one new link. I'm sending
Okay.
soon one new link to join.
Okay.
Okay.
Yes, now let me know. Is my screen visible now?
Yes. Can you just type something?
Yeah, I'm going to type something here. Yeah.
Yes.
Yeah.
So IP EIGRP topology on router number 2. So what is FD for 20 network? 28160. FD is 28160. Yes,
Yes.
this is FD. FD means total distance, means router 2 have calculated this metric for this network. How? By putting the value in formula. Now if I will talk about R1, so R1 will also calculate FD. Also calculate FD metric. So metric on R1 will be what? Metric on R1 is 30720. 30720. So I am going to put this metric over here. 30720. This is FD. Means total distance from router 2 to reach in 20 network is this one, and total distance from router 1 to reach in this network is this one. Router 1 will calculate one more thing, that is RD. RD. What will be the RD? RD is nothing but, guys, FD of their neighbor. Who is advertising this prefix 20 prefix? Router 2. And what is the FD of router 2? 28160. So this will become RD. Getting my point? This is for which network? For 20.1.1.0 network. Here also this is for 20.1.1.0 network. Now R2 is not going to calculate RD because R2 is not receiving this network from their neighbor. R2 is advertising this network, yes or no? So RD over here will be what? RD over here will be 0. Getting my point? So RD is what? RD is total distance from my neighbor to destination, and FD is what? Total distance from me to destination. Getting my point? Here, let's say I am in India. I am here. Let's say not in India. In India, in a single city. This is Praful. PM. PM is here. After that, Abdul is here. And then Soha is here. Let's say Soha is here. Right? Guys, distance between PM to Abdul is, let's say what? 10 kilometer. 10 kilometer, and distance between Abdul to Soha is 20 kilometer. Getting my point? So if I want to, send something to Soha, total distance will be what?
30.
30. So that will be FD. FD will be 30. And RD will be what? Who is my neighbor? My neighbor is Abdul. What is the total distance from Abdul to Soha? 20. So that will become what? RD for me. Means my neighbor to destination, because who have told to me about the Soha? Abdul. Abdul told me that if you want to send something to Soha, you have to send it to 20 kilometer far away. Getting my point? Okay, for Abdul, FD is 20 kilometer, and RD is, RD means distance from neighbor. Who is neighbor? Soha. So maybe Soha is advertising some distance like 10. So 10 will be RD for you. And here RD will become 0. RD will be 0 because Soha. So I want to send something to Soha, not to Soha neighbor. Getting my point? There is some difference between FD and RD. So FD is feasible distance, and feasible distance is nothing but total distance from source to destination. RD is reported distance, total distance from my neighbor to destination. From my neighbor to destination. Total distance from router 1 to this network is 32720, and total distance from router 2 to this network is 28160. So this will become RD and this will become FD. Is it clear to everyone?
Yes.
Is it clear to all people? Yes. Now what I am going to do, let's say I am going to add one router over here. Now one router, we have one router here, R3.
Are you recording?
Yes, recording is on. Let me connect this router also. Now, if router 1 we want to reach in 20.1.1.0 network, how many paths router 1 have?
2.
Now router 1 have two choice, yes or no? It can forward traffic to router 2 or to router 3. Let me add this network first. On router number 1, I am going to configure one IP address on F0 1/1, which is connected to R3. interface. Let's say here I am using which network? 13.1.1.0/24. This is network between router 1 and router 3, and between router 2 and router 3, let's say I am using 23 network, 23.1.1.0. Done. So on router number 1, I will run command interface f1/1 no set and IP address. What will be the IP here? 13.1.1.1 255.255.255.0. I need to enable EIGRP on this interface also. So router EIGRP is number 10 and network 13.1.1.0. So now if you will check, so IP EIGRP interface, you can see EIGRP is running on three interfaces. Yes. Now let me take you to router 2. On router number 2 also I am going to add one interface, config t interface f1/1, say no set and IP address. IP address over here will be 23.1.1.2, let's say 255.255.255.0. Then router EIGRP is number 10 and network 23.1.1.0. And so IP EIGRP interface, you can see we have enabled EIGRP on all three interfaces. Now let me take you to R3. And on R3 I am going to configure IP first. Config t interface f1/1, say no set and IP address is 13.1.3. 0 exit interface f0/0 no set and IP address is 23.1.1.3. Done. Now router EIGRP is number 10 and network 13.1.1.0 and network 23.1.1.0. so IP EIGRP interface. So we have enabled EIGRP on both interface. So IP EIGRP neighbor. So you can see there are two neighbor of router 3. Done. So IP route EIGRP, it have learned this network and this network, 10.1.1.0 also and 20.1.1.0 also. So IP EIGRP topology. Inside the topology table, like see 2L network. 2L network means network between router 1 and router 2. Here we are running 2L.1.1.0. Router 1 is also advertising this network and router 2 is also advertising this network. Yes or no?
Yes.
Both router are advertising. So how many successor we have?
2.
Okay, successor means best path and feasible successor means backup path. You know we have four terminology. One is feasible distance, one is reported distance, one is successor and another one is feasible successor. So FD is total distance from source to destination, RD is total distance from neighbor to destination, successor is best path and feasible successor is backup path. Backup path. Done. So now again let me explain the scenario. See, scenario is here we have 12.1.1.0/24 network, router 1 and router 2 both router are advertising this network. Yes or no?
Yes.
And when router 3 is advertising 13.1.1.1, that time metric is this one, this is FD and this is RD. First value is FD, second value is RD. So when router 3 is advertising, it is advertising with FD 30720 and RD 28160. When router 3 is advertising, it is also advertising with same FD and same RD. Am I right?
Yes.
So router will perform what? Load balancing. Router will perform load balancing because FD and RD from both sides is same for 2L network. So IP route EIGRP. You can see for 2L network it is performing load balancing. How many paths we have in routing table? 2 paths. If router have installed 2 paths in their routing table, that means router is performing load balancing. Now question is why router is performing load balancing? Because from both sides it is calculating equal FD and equal RT. Now let me take you to R1. Very important. R1, here I have router 1, so IP EIGRP topology. In topology table for 20 network, we have only one path. We have only one path. Yes or no? Why alternate path is not showing, guys, here? Because we have one more path via router number 3 to reach in 20 network. Am I right? See, I am on router number 1, and router number 1 we are able to see EIGRP topology table. Inside the EIGRP topology table there is one network 20.1.1.0/24, and it's showing there is only one successor.
Yeah.
But how many paths we have?
2.
2. Then why it's not showing other path? Because there is one feasibility condition. There is one feasibility condition. Now feasibility condition is what? Feasibility condition is, guys, FD of successor must be greater than RD of feasible successor. Now this path is my feasible successor. Let's say this path is feasible successor and this path is successor. Means this path is best path and this path is backup path. But we are not able to see backup path in EIGRP topology table. That means this feasibility condition is not matching. That means this feasibility condition is not matching. See, if I will down this interface F0/0, for now what I am going to do, I am going to calculate, I am going to note down FD and RD via router number 2. This is FD and RD. Here I have copied it and let me paste it over here. This is FD and RD via which router?
1.
Via R2. Via R2. Now I am going to down interface F0/0 of router 1. I am going to down shut down. Now how many paths we have?
One path.
Only one via router number 3. So IP EIGRP topology. For 20 network, path is
1.
via router number 3. And this is FD and RD. Let me write here.
So now we don't have backup path, right?
Now you tell me feasibility condition is matching or not over here. See, FD of successor. FD of successor is what? FD of successor means upper path is 30720 must be greater than RD of feasible successor. RD of feasible successor is 30720. See, feasibility condition is not matching. Yes or no?
Yes.
That's why router 1 is not installing alternate path. So it should be very clear to you that router install which path in their topology table. So router install only two paths in their topology table. One is successor and another one is feasible successor. But for feasible successor, we have one feasibility condition, that is FD of successor must be greater than RD of feasible successor. If this feasibility condition will match, then router will install both feasible successor and successor in their topology table. Otherwise, it will install only successor path. Any doubt till here?
No.
Is it clear to everyone?
Yes.
It is
Yes.
very simple. Just I am saying that router installs successor and feasible successor in their topology table. Again, I am going to up F0/0 interface F0/0. Say no, sir.
Is it important to learn this thing like if DO or SR?
It is important to understand EIGRP topology table. It is important to understand EIGRP topology table that a router install how many prefixes in their topology table, which type of prefixes. So by default, it install two prefixes, successor and feasible successor. But there is one feasibility condition, that this is only concept. So IP EIGRP topology. Now you can see in topology table, this network is available via router number 2. Now it should be very clear to you that why router 1 have installed this prefix via router number 2. Why, guys? Because it is calculating least FD via router number 2 as compared to via router number 3. Getting my point? So anyone can ask you that router 1 have two choice to reach in 20 network. Either it can reach via router 2 or it can reach via router number 3. So why router 1 is reaching via router number 2? Why router 1 is reaching via router number 2? Because router 1 is calculating least FD via router number 2. See, FD via router number 2 is this one and FD via router number 3 is this one. So it is calculating least FD via which router? Via router number 2. As you know, list metric is more preferable. Okay. Is it clear?
Yes.
Any doubt?
Nope.
Not till here. Now we have simple features also in EIGRP like RIP protocol. In RIP we have automatic summarization. So here also we have automatic summarization. So IP protocol by default automatic summarization is disable. Okay, then maximum hop that EIGRP can support is 100, but we can change this value. This is by default. In RIP protocol support only 15 router. Yes or no? RIP protocol support only 15 hops, not more than 15 hops. Here we can say maximum, not path. Here I have one command maximum. This is command to change maximum path. By default it can install how many path? 4 path. So if you want to set 16, so you can configure like this. Now if you will run command so IP protocol, so you can see the maximum path that this router can support is. And let me do one thing, config t interface f0/0 IPEAGRP. I'm able to run command like this. Here I can find the command. This is command. On router number 1, we will say a router EAGRPS number 10 and metric maximum hops. Maximum hops, let's say 200. And so IP protocol.
Still 16.
No, 16 is different. This is maximum path. How many paths it can install? Maximum hop count is 200 now. Maximum hop count is 200. Maximum hop count means how many hop are allowed in EAGRP. And this is maximum path means how many maximum path it can install in the routing table. Like router 1 have 2 paths now. Router 1 have 2 paths. See, if I will connect one switch here on router number 3, and here also I will run same network command, let's say. Here, let's say also I am running same network. This network 20.1.1.0/24. So what will happen? Both router 2 and router 3 will advertise same network information to router number 1. So this time a router will receive 20.1.1.0/24 network from two sides with equal cost, with equal metric from both sides. So router 1 will perform what? Load balancing. Router 1 will perform load balancing. And on router number 1, guys, it will install how many path? Router 1 will install how many path for 20.1.1.0? 2 path. In the routing table, if you want to see, so directly I can configure IP address on this interface f1/0. Interface f1/0, say no sat, and IP address is 20.1.1.1 and 255.255.255.0. Exit router EAGRPS number 10 and network 20.1.1.0. So now I have advertised 20 network on router 3 also. If you want to see the routing table of R3 or topology table, so IP EAGRP topology. Now you can see 20 network. For 20 network, how many paths are there in topology table? 2?
Yes.
How many paths we have? 2 paths. And from both sides, RT and FT is same. So router 1 will perform what? Load balancing. So IP route EAGRP, it is performing load balancing. It will forward 50% traffic to router 2 and 50% traffic to router 3. Am I right?
Yes.
So IP protocol. Router 2 have installed 2 path because maximum path configured over here is 16. Means it can install 16 path, up to 16 path in their routing table. But if I will configure maximum path 1 over here, router EAGRP AS number 10 and say maximum path 1. If I will set 1, now this router cannot install more than one path. So IP EAGRP topology. Inside the topology table, how many paths we have?
1.
2. And so IP route EAGRP, how many path? Only 1 via router 2. So inside the topology table, still 2 paths are available with equal cost, with equal FD and equal metric, but still router 1 is installing only 1 path in their routing table. Why? Because maximum path configure is 1. Getting my point? This is the concept of maximum path. This is how many path EAGRP router can install. So I can say router EAGRP as number 10 and maximum path, let's say 5. So now it can install 5 path and it will again install 2 path in their routing table. So IP route. Fine.
So if they have one path, then they're supposed to receive the network from, all the information from the same one path, not from the other one, from router
Okay.
3, not router 2. So how they can receive information from router 2?
Can you repeat your question again?
Okay, you say we can use one path, right? If router
Okay.
1 one path, for example, from R1 to
No,
R3.
it can use any path randomly. It is random.
Okay,
There is no any concept of that, right? It can install any one path.
but it gonna use one of them.
Yes, one of them. Randomly, it will use one of them.
And before this question, you says like if we have like 16 path, like both path is open, and the router 1 will receive the network information from both. They can receive from both path on the same count, everything is same. Why? Because they are like
Okay.
they have 2 routers, and in the middle, when they send from router 3 to router 1, is shortest path. Why they don't use this one? If they use they use like router 3, then router 2, then from router 2 to router 1, it takes too long.
Yeah, actually, this path is also available. See, if router one have, see how many path to reach in 20 network. One is this path to reach in 20 network. One is this path to reach in 20 network. One is this path, and one is this path. Yes or no?
Yes.
But when router 1 will use these 2 paths, then metric will be higher than this path and this path. Yes or no?
Mhm.
So that's why it is not installing this path and this path. Because here router 1 is calculating more FD and RD. Getting my point, brother?
Yes.
Always keep in mind, whenever router 1 have more than one path, right, with same metric, then maximum path should be configured as at least 2, because in real time you should have one backup path, that if your primary path will goes down, there should be one alternate path. Getting my point? In real time, let's say this is my topology, R1, R2, R3 and R4, and let's say R4 have some prefix. R4 have some prefix A, B, C. Now if router 1 want to reach in this network, how many paths router 1 have?
2.
2 paths. But in real time your requirement can be like router 1 should forward all traffic in ABC network via router number 2 until and unless router 2 is up. If router 2 is down, then router 1 should forward traffic to router number 3. So here in this scenario, router 1 should have use both path, upper path as well as lower path. In next class I will make you understand with this type of topology how EAGRP works. Then we will discuss default route as well in EAGRP. We have concept of default route, and now on router number 1, if you will run command show IP protocol, so IP protocol, so here you can see external metric. We have external metric as well, so we need to discuss this also. Maximum path configure is 5 over here. And hop count is what? Hop count is different thing. See, when router 1 is getting 20 prefix, 20 prefix is how many hop away from router 1?
19.
1 hop away. Only one router is between router 1 and destination network. I'm not talking about administrative distance value. I'm talking about hop count. Hop count means router. How many hops are there? 1. So IP EIGRP topology. See, inside the topology table this network is available. And this network is how many hop away? So 1 hop away. There is only one router. Getting my point? See guys, what I am going to do, let me do one thing. First of all, I am going to down this network which is running on router number 3. Let me down it on router number 3. I'm going to remove this command from here, say no. Now router 3 is not advertising any 20 network, only router 2 is advertising. Done. So again router 1 have two paths. One is via router 2 directly and one is via router number 3 to reach in 20 network. So IP EIGRP topology. Now you can see router 1 have installed only one path. Via which router? Via router number 2, because lower path is not best path. It is calculating higher FD value. Now I am going to down this interface. I'm going to down this interface. So router 3 will learn this network via which router? Via router number 3 by using this path. Because now router don't have this choice. This path is now not available. So definitely router 1 will install this path in their topology table. Yes or no?
Yes.
So see, if primary path will goes down, interface F0/0 and say shutdown. Primary path is now down. So IP EIGRP topology. Now you can see this router have not installed 20 network. Soon it is going to install 20 network via which router? So IP EIGRP neighbor. Let me check neighbor once. Why there is no neighborship between router? Okay, neighborship is fine between router 1 and router 3. Why there is no any neighborship between router 1 and router 2? Because this link is down. Am I right?
Yes.
And so IP EIGRP topology. Inside the topology table, we are not able to see 20 network. Why I'm not able to see 20 network? Because R3, see R3, so IP EIGRP topology, R3 is installing 30 network via which router?
Router 2.
But FD is what?
Infinity.
Infinity. This is the reason. So it will take some time. After that it will install 20 network via router number 2. So IP EIGRP topology, or so IP EIGRP neighborons. So neighborship is fine. So IP EIGRP topology metric is infinity. Why metric is infinity? Because this network router 3, so IP router 3 have this network directly connected. So why it will learn this network from EIGRP if this network is directly connected with router 3? So I am going to remove this configuration from router 3. I'm going to remove this network command. Interface F1/0 say no IP address. Once I have removed this network on router number 3, you will check so IP route. Inside the routing table, are you able to see 20 network? And this time next hop IP address is this one, right? And this is matrix, this is AD value, and so IP EIGRP topology. Now EIGRP topology, inside the EIGRP topology also you can see 20 network is here. FT is this one this time, not infinity. Done. Now router 3 will advertise this network to router 1 and router 1 will also learn it. Done. 20 network. Now you tell me how many hop this network is away from router number 1?
1.
2 hop. Router 2 and router 3. 2 routers are there, na?
So which network you just remove it from router 3?
Actually, no, router 1 is getting this network, sorry, this network via router number 3. Here router 1 is getting 20.1.1.0/24. So how many hop are away? How many hop this network is away?
Two hop.
Away. 2 hop away?
Yes.
2 hop away. So if I will configure maximum hop 1 over here, so it will never accept 20 network. Getting my point? See now, so IP EIGRP topology, inside the topology table 20 network is there, and inside the routing table also we can see, so IP route EIGRP 20 network is here. Done?
Yeah. So I'm confused here. When you shut down one interface from router 1, you shut down facet 0/0, right?
Yes.
The connectivity between R1 and R2 is
Down.
right, is gone. So
Yes.
it should, router 1 should have received information from network
R3
.1.1.0 through
20.1.1.0. Yes, from R3.
from through R3, yes. But why you remove network from R3? Which network you remove it before
I
it?
have removed this network. If see router 1 have this network already, then why it will learn from
Okay.
EIGRP from their neighbor? So that's why I have removed this command from here.
Okay, this network is no more in R3. So okay.
Yes. Now router 3 don't have any choice. It have to learn 20 network.
Got it. Okay.
And when router 1 will learn this network via router number 3, then hop count will be 2.
Yes.
Total number of routers is 2 between destination network and router 3. And if on router number 1, I will set hop count 1, router EIGRP 10, and say metric maximum count is 1. So now it will not accept the 20 network. So IP EIGRP topology. Why 20 network is not here?
Because we got 2 hop here and you just
Yes, because we have configured 1 hop. So these are the troubleshooting. Sometimes you will see in real time also your EIGRP network is not working fine. So these things can be the reason. Okay, so here at least we should configure maximum hop is router EIGRP as number 10 and metric maximum. Here at least maximum hop should be 2.
but we can use
Yes or no?
we can use like 100 or 200 whatever.
Yes, you can use, like you can see the range 1 to 255.
Okay.
Okay, so I have set it to, and so IP EIGRP topology. Again, it have installed 20 network. Yes or no? But router will not receive any prefixes which is coming from 3 hop away, because maximum hop allowed is 2 only. Getting my point, guys?
Yes.
Done. So this is concept of maximum hop count and maximum path. First we have discussed maximum path, then we have discussed maximum hop count. Now, so IP protocol. By running this command, okay, so these are the gateway, these are the routing information. Maximum path is 1, automatic summarization is disabled, maximum hop count is 2, distance internal is 90, external okay, we will discuss it tomorrow. And now we don't have much concept left in EIGRP for CCNA student. Rest concepts are very advanced concepts that you will learn in CCNP or CCIE. Okay, so this is all about today we had discussed what? EIGRP topology table, EIGRP routing table, and EIGRP neighbor table. We had discussed how to configure EIGRP. We had understand what is dual algorithm, means how many terminology of dual algorithm, and what is FD, RD successor, feasible successor, what is feasibility condition. Then we have discussed how to manipulate maximum path and hop count, maximum hops. Done, guys. Now I am going to down the all routers and let me close the lab. If anyone